Okay, so a little bit of review, how the body can regulate pH in the blood. So through two systems, the respiratory system and the metabolic system. So there's things that the respiratory system can do. It can either increase or decrease the carbon dioxide content, and the metabolic system can either, through the kidneys, either increase bicarbonate or H plus ions, or can decrease either one of them. Okay. Now, this pretty much can be ignored when we're doing these types of problems. Okay. Carbonic acid. So let's go through a few things. Okay, so we've got the H plus here. Basically, the H plus is going to tell whether we're acidic or basic. So if we have an increase in H plus ions, that means it becomes more acidic, according to the Arrhenius definition, and the pH is going to be lower, so lower than 7. Conversely, if the H plus ions decrease, it's going to become less acidic, so more basic, and it's going to have a higher pH. Okay, so let's say maybe hyperventilation. So hyperventilation blows off a lot of oxygen, so gets rid of it in the blood. So that decreases the concentration of CO2. And if we decrease that, it's going to shift equilibrium towards. So take towards. What's going to happen to these two? Both of these are going to go down. And what we really care about is the H plus. Decreasing H plus is going to make it more basic, so it's going to have a higher pH. Okay, let's say the kidneys remove bicarbonate ions. So bicarbonate goes down. Take goes towards, and H plus is going to increase. Okay, conversely, if the kidneys removed, increased bicarbonate, there we go, up arrow, increased bicarbonate, add is going to go away, so H plus is going to go down. So less hydrogen ion means more basic, pH is going to be a higher number. Okay, let's say the H plus ions, the blood is very acidic through maybe a disease or something, and how would we reverse that process? So we have too much hydrogen ion. How are we going to lower the pH, basically, is what we're asking. So how we're going to lower the pH, basically, is what we'll do. Get rid of that arrow there. So how do we want to decrease the H plus concentration? So it's too acidic. We want to get rid of some of it. Well, there's a number of things you could do. Basically, what we want to do is we want to shift equilibrium to the left, because that will cause H plus to go down. So we can increase bicarbonate, which uses up the hydrogen ions, or we can remove CO2. Okay? And either of those are going to decrease the hydrogen ion concentrations. That's one scenario. Okay, so let's say the respiratory system is causing alkalosis. Let's say acidosis. Okay, respiratory system is causing acidosis. What can the metabolic system do to compensate? Okay, so how about this? Respiratory acidosis is caused by what? Well, if we're respiratory, it means we're talking over here on the respiratory system side. Whoops. And so what would cause acidosis? Basically, acidosis is making it more acidic, so increasing hydrogen ions. Okay, so that would be shifting equilibrium to the right. So if we're looking at that, that would be increasing carbon dioxide concentration. And we call that hypoventilation. Okay, so you're not getting enough carbon dioxide. You're getting too much carbon dioxide in your blood. And that would typically become as a result of slow breathing and shallow breathing as well. So that would be hypoventilation. Hypo means less than, hyper means greater than. Okay, next couple things. Let's see, lactated ringer. What that does is it has sodium lactate in it. Lactate is metabolized by the kidneys to produce the bicarbonate ion. So what it does is it helps to balance out your pH by producing more bicarbonate. And if you add bicarbonate, so if we increase bicarbonate, it's going to shift away, add away. So that's going to cause the hydrogen ion to lower, so become more basic or closer to neutral. Okay, bicarbonate really is acts as a buffer. And some good buffers would be NaHCO3 because that ionizes into bicarbonate, or something else that ionizes as well. And really a buffer is a conjugate. So here we have an acid. Here's its conjugate base. So a good buffer is a conjugate base because it helps to drive equilibrium to the left and use up those hydrogen ions.